Electricity is dangerous.
Hey, what's up everybody? Jack's Electric here. Today we're going to explain to you guys how to wire a stop-start station that controls a three-phase contactor. I think that it's important to note that because you see down here this set of holding contacts that this is a 3-wire low voltage protection scheme. And all that fancy stuff means is that if you lose power, somebody's going to have to come over here and find a start station to fire that motor back up again. In some instances it makes sense, in others it doesn't, and I'll let you figure that stuff out because it's not relevant to what we're talking about. Okay, so this symbol right here is a stop station. This is normally closed, which means these contacts are normally closed with this here. This is a momentary push button. If you push down on this push rod here, this little bar will come down and then spring return up when you let it go. Same thing with this, just opposite. This is a normally open start station. This bar here will allow electricity to flow. Let's just take a look at it here. I'll show you. Between these two contacts, if there was electricity here now, it could flow across, wait out right here. You press this button, and then it can jump across to this set here and go do work. Okay. Further over here, you see L1, L2, and L3. This is just your feed. And because you see this black, red, blue, that means that it's going to likely be 208, 230, 3-phase. These are just armatures here of a disconnect. This dotted line represents a handle tie, which means that if I were to close L1, L2 and L3 would have to close. This is so you don't get any dangerous situations for the motor or personnel. It's all or nothing. All 3 legs will close together and all 3 will open together. Okay, it's in the code. I'll let you look that up. Coming further down, you'll see some normally open contacts here. This M is just reminding you that that belongs to this coil, and this schematic is actually the daddy of all of this. T1, T2, and T3, all that means terminal 1, terminal 2, and terminal 3. These plates here and here do not care what you put on L1, L2, L3, or T1, T2, T3. When this coil gets voltage, it's going to close it magnetically. Okay, you could put any voltage, 8 volts up there if you wanted, and it's going to be present on T1 once that magnet closes. That's all that means. Okay, underneath that you'll see that these reverse C's, all this is some heat sensitive metal. All metal is heat sensitive, but you know what I'm saying to you, right? These are overloads. An overcurrent, friction from all the amperage is going to cause these pieces of metal to peel away from each other, and this is a pretty accurate depiction of what an overload does. Makes sense, right? So that it opens up in the event that something's too hot to protect your 3-phase motor down here, which is what we got right there. All right, so now that we talked a little bit about what we're looking at, let's get this thing going. Let's try out this push button here. You'll notice when I push this button down that this coil lights up. This normally open set of contacts has now gone to closed because you allowed the voltage that was hanging out here and here to jump across here, which changes the state of this guy. Now it's normally closed, and then when you let go of that, this is going to stay running. Okay, you change the state, it's now magnetically held, and then you would press that stop button right here, which breaks the magnet and then breaks the voltage, and then you have to start over. Okay. Alright, so now the next step that we take is we number our conductors on the schematic. So I'm going to take your, we're going back down here. This is your schematic. So it looks like the first place to start is going to be from L1 to the stop station, feeding into the stop station. Then we'll jump across and we'll come from L2 to your return through the overloads, or to the overloads. Looks like conductor number 3 here is going to be between the stop station and the start station. Conductor number 4 is going to be on the load side of the start station, or the right side, and that's going to feed it, that's going to go to your coil. It's important to note that you see that there's a parallel set of conductors here. 3 and 4 are paralleled. And then 5 is going to be between your overload and your coil. Okay? So now that we've got them all here, and they're numbered, it should be pretty simple to install them up here on our wiring diagram. Let's start over here with L1. Looks to me like L1 is going to be able to get drawn in to the stop station. Okay. So once we draw that in, you'll see that now we've got it here. Remember, these lines that you draw in a wiring diagram are only representing conductors that you'll install in the field. So we took a little tap here on the load side of the disconnect, right? And then we just ran our voltage all the way to here. And then we label everything. So I got my little number one here, number one here. Once you label it, you can see that we've got our conductors here, which represents the one down here on the schematic. Then you make a check mark, okay? Please make check marks. Let yourself know that you've got it taken care of. For a schematic like this, it really won't matter. When you're dealing with a ladder diagram that has 17 rungs on it, I promise you, you're going to want to label everything. You blow this stuff up and your boss doesn't care that's, the reason why. We've just got to start over. All right, now we're going to go to number 2 here. I like to do the return after I do the feed. I typically start with the return, and I've heard a lot of nonsense from a lot of electricians about it. When I'm wiring stuff on schematics, I start with the return all the time because you should never switch it once you're dealing with control work. So once it's out of the way, now you're just dealing with your controls. So again, we got a tap here on L2. Looks like we're going to do a little jump here. For those of you that aren't familiar, anytime that you have a conductor that crosses a conductor, you should make a little hump here. It's not through my overloads because I wanted it to go through those. And that's going to feed the set of overloads. Okay, now let's go to the other side again. Number 2, we got number 2, and then we go through our check mark. Done. Okay, here comes number 5. You might as well finish this return right to the load. And this load is going to be a coil because it's going to cause the work to happen. So now we've installed number 5 here on the coil, and you'll see that we can represent it. Got it checked off, and then we move on. Let's connect number 3 now. Number 3 is going to be here. If you're looking down at the schematic, it looks like it's coming out of the right side of the stop station and going into the left side of the start station. You should absolutely do that. If something comes into the left side, then wire it on the left side of your wiring diagram, and etc. Okay. Number 3 is all set. Moving on to number 4. Boom. We'll get this guy a little wired up here, which comes out of the right side of the start station, and then it goes down into the coil. The right side to the coil. Okay, so number 4 is going to be all set. We've got number 4. Let's give it the old check mark. Let's hit our parallels now. Looks like we got a normally open contact here. You'll notice that I put this line right here. Okay, not off of the termination. Okay, this is going to be a cleaner installation of this on our wiring diagram. It means the same thing. This wire is common with this conductor here, so it wouldn't matter if I hooked it up here, 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 anywhere. So to keep the lines nice and straight, I just did what we did. Now number 4 is going to be all set to parallel to number 4. Might as well parallel to number 3 now. We'll draw that in. Once you draw that in, and again, this 3 represents this parallel 3 down here. And we can give that the old check mark. Once all this is wired, okay, you should get rid of your numbers. They're confusing. These numbers only represent your conductors, not terminations, right? So let's just go ahead and drop those things out here. Let's get rid of them. Now we're going to add a few things. First thing I want to tell you before we add anything is that if you had your start-stop station here and here, and you've got your contactor over on this side, this is where this 3-wire control scheme comes in, okay? You'll notice that if you draw a circle in between your 2 and then count the conductors, that's how many you're going to be controlling. That's how many are in your pipe. So that's an easy explanation for the 3-wire control, okay? Because if you were looking at that, you saw we had 5 separate conductors marked. How could it be 3-wire control? Well, out to your start station, out to your stop and start station, you're only needing these 3 conductors, and that's why it's a 3-wire control, okay? So we'll get rid of that. Now I'm going to add a few things that I didn't put on initially on purpose. I don't need you guys getting confused by more lines. So as I close these conductors, you see that we close those. You see that we're adding some dotted lines here, okay? This coil and this contact are usually mounted on the front of your contactor. So that's why we've got a dotted line over here, and that's why we've drawn them kind of close to these 3 normally open contacts. That's also worth noting that this coil is very typically marked A1 and A2 for auxiliary contacts. Auxiliary meaning they're not the main set of contacts, okay? So don't let that stuff intimidate you. Now let's get to testing this out, okay? We're going to hit this push button again. As we hit this push button, you have now allowed the L1 to come in. When through your normally closed start station, once you hit this start button, it's now going to hit this side of A1. And obviously on this side, it's going through, was normally open, now is normally closed because L2 has voltage on it as well. Now you'll notice that these three contacts have now closed, meaning anything from L1 is now T1, L2, T2, and L3, T3. It's also represented down here on your schematic. All of this is now a circuit. And then you're going to notice that your motor is going to be running. Okay? So your three-phase motor is going to start up the second that you press that button. When you let go of that button, it's actually going to continue to run because it's being magnetically held now, just like we discussed earlier. It's magnetically held. So if you wanted to stop that from happening, any one of these things can open it. Any overload, okay, an overload will stop that. A stop station, if you stop this, it'll stop it. And if you open this, if you open your three-phase disconnect, obviously it doesn't have a feed anymore. And that will stop it as well. Let's just keep it easy. And I'm going to engage the stop button. You hit the stop button. Now we've broken the magnetic coil, which means we're ready to just start the whole thing over. Okay? And we'll let go of that button, open up the disconnects, and we should be all set. So if you had any questions, feel free to let me know. You can put them below or email me at ezelectrics. That's EZELECTRIX @gmail.com. Thanks, guys.